Let's look at question 2 now. So the two yogurts tested by the visitors were actually the same products. The only difference was the label. So we want to know whether the label influenced the amounts that the people are willing to pay for those yogurts. These are the hypotheses. Whether the average willingness to pay for the first brand and the second brand are the same or not. Now, based on that, we took based on the sample of 61 people, we took the standard deviation of the differences between the amounts that are willing to pay for the products, and that standard deviation of the difference is 1.42. Now, what's the absolute value of this test statistic? First thing, what are we testing? So we are testing here a difference between the willingness to pay. We're testing differences between sample means. But the idea is that the sample means are not independent from each other, since the same 61 people tested two products, so they have a dependency. The willingness to pay depends on the same people. They both taste the product and they say how much they're willing to pay. So this one tested the first yogurt, that was not a Y, not a 1, anyway, a hybrid. Y1, and over here Y2. So that's the dependency. And when we have a dependency, basically the same sample doing two actions, or basically from the same sample, we derive two subgroups, we're calling this a matched pairs t-test. So we're calling this a matched, because they are matched, right? They're matched with this one, with the number of observations, matched pairs, t-test on differences. So it's a t-test on differences between means. Now, how do we do so? Well, we want to know whether that difference is going to be significant or not. Mainly, we're going to take the difference between the sample means, because the sample means estimate the population means. We're using the same logic. So the difference between the sample mean of the first group, which is $1.5 that people are willing to pay on average in this group for the first yogurt, which is organic, minus the sample mean of the second group, which is $1.14 that are willing to pay for the regular yogurt, and we divide that by the standard of error. And the standard of error is going to be the standard deviation of these differences. So the standard deviation of this difference is divided by the square root of the number of observations. Now, it's a matter of math again. We're going to see what that is. So recall, this is very similar to what we've been doing so far. If you recall the one sample t-test, what did we do there? I'm going to put it here as a side note. We were taking the difference between the sample mean and the population mean to see whether the sample mean differs significantly from the population mean. In this case, we're taking the sample mean of one group from the sample mean of the second group to test the same logic. Are they different enough or not? And to compare it in standard units, we divide that by the standard error. Hope this makes sense. Now, let's just substitute the numbers and see if the math works out. So we're going to have here 1.5 minus 1.14 for the mean of the second group divided by the standard deviation of the differences, which happens to be 1.42, that's given to us, over square root of 61. Over square root of 61, if we solve it, we're going to get 1.98. So the math over here is going to be 1.98. The answer key tells us that it's 1.98, so the answer is true, and we are done.